Okay, let's look at the homework 3.3, problem number 2. All right, so we have the graph of f prime. Then we need to answer these questions. All right, so let's do that. So on what intervals is f increasing? All right, so we're talking about f, and the given graph is f prime. All right, so in order for the function to be increasing, derivative has to be positive. Right, so you can see that here it's above the x-axis, so it's between let's see, 2 to 4, right? So we have on what intervals? So between 2 to 4, right? Then after that, so maybe I'll use the set notation, and also 6 to 9. Right, so we have that, and let's see, and part B, what value of x does f have a local maximum? Right, so it's a first derivative test. So you can see that the critical numbers are right here and here and there, since that derivative becomes 0. This is an endpoint, so we're not going to look at that, but here. Right, so you can see that we want the local maximum, so it's a decreasing to increasing, right? So that's not there. But here, increasing to decreasing. So this is going to be produce the local maximum. So at 4 is one of them, right? And here is decreasing to increasing. So it's a local min. So 4 is the only one. And as we said, local means the other two. So it's 2 and 6. 2 and 6, right? And also, on what interval f is concave upward, which means that the derivative has to be increasing. So derivative's increasing, right here, 1 to 3. So I'll put that 1 to 3. All right, then put the union there, and the scroll back up. So this is decreasing. So 5 to 7 is also increasing. So put 5 to 7. Right, then last part is let's see, 8 to 9. So right, so union 8 to 9. Right, so for intervals of concavity, we usually use the parentheses, right? But for the increasing, decreasing, usually we use the square brackets, because they're inclusive. Right, concave downward, so it's other places. So it's decreasing 0 to 1. All right, and also let's see, decreasing here, so 3 to 5. All right, and the last one, it's decreasing 7 to 8. Right here, oops. All right. All right, so part D, we want to find the x coordinates of the inflection points. All right, so let's look for that. So inflection points, so second derivative is equal to 0. That's going to give us a clue. But if the second derivative is 0, which means that the first derivative will have a horizontal tangent line. So you can see that there's going to be here at 1, and at 3, and at 5, at 7, and at 8. Right, so let's see if it's a concavity changes there. Right, at this point, right, so it's a decreasing to increasing, indicates that so if the first derivative is decreasing, the original function is concave down. If the first derivative is increasing, it's concave up. So concavity changes, so that translates to change in increasing, decreasing in f prime. So here at 1, it changes concavity. At 3, it changes concavity. And at 5, it also changes concavity. 7, it changes concavity. And at 8, also changes concavity. So so it's going to be 1, 3, 5, 7, 8. Oops. So 1, 3, 5, 7, and 8 will have inflection points. All right, so let's double check. Submit for testing. All right, it came back and it looks like we got part A correctly, and part B, and part C, and part D. All right, that's it. I hope that this was clear.